Hello fellow computer enthusiasts, my name is Christian, hope you're doing well today. Welcome to the first episode regarding the exploration phase of our game programming series called From Scratch to Steam, where I would like to show you how to develop a video game from the first idea up to the point when we will upload the final release to the Steam store. In today's video, I will cover the process of brainstorming and prototyping of the RPG tower defense idea that we have created in the last video, and I will teach you how to start a project and how to organize it in Unity. In our previous episode, we learned two important things about the game development process. First, we have to start with some sort of an exploration phase where we figure out if our game idea is worth a project. That's where we create a playable prototype and see if it makes already fun to play, or if we have to further improve our idea, or just to throw it away and to start with a great new idea, right? The second major thing we learned in the last episode is that we have to maintain constantly shippable source code, meaning that we polish as we go, and every working piece of software that we create should be in some form or another that we can reuse it in other prototypes and games as well. But before we'll have a deep dive into the first coding topic, the character controller of our upcoming From Scratch to Steam game, let's have a short look on our game idea and what we want to achieve. The idea is to create some kind of a tower defense game with RPG and roguelike elements, where the player has to build a village to hire heroes and prevent enemies from destroying the village and the surrounding areas. We plan to have a turn-based combat system where the player has to place the defending heroes in some sort of a planning phase before the enemies attack in a real-time combat system and try to reach their specific goal. That could be to destroy a certain building on the map, to steal resources, or just to reach a specific point like crossing a road or something like that. After each enemy wave, the player is allowed to adjust the hero placement and equipment in order to improve the defense line before the next enemy wave will attack. The player will win the combat situation by holding specific level goals, like keeping the buildings or points or something like that. After each combat, the player returns to the village in order to further improve the buildings, hire and equip new heroes, and finally build a dark portal to win the game. Oh, I forgot to mention, the overall story is something like a young boy or girl fell into sleep after watching a fantasy series in TV, and he or she wakes up in a new village where a mystical dragon or some sort of a magical creature or someone else tells her or him there is a dark portal that needs to be built in order to save the dream world and return to the real world. I mean, come on, the story doesn't matter for the actual gameplay. It's in our case more like a setup to define what's allowed and what feels displaced in the fantasy environment, right? But enough with the overall game idea, let's get into today's topic and figure out what makes a good class design for reusable characters in video games. For our actual game, I use a game engine called Unity 3D, in which everything that exists in our game world is something called a game object. These game objects can get abilities by assigning components to them that allow these objects to interact with the real world. The best way to treat a game object is to see them as some kind of a self-contained system. Imagine you are creating a group of adventurers that go out to discover a dungeon. Every character in this party is a self-contained object that can move, attack and do other things without a manager class or something like that. And we try to keep the dependencies to other game objects as minimal as possible by designing our game object. So currently I stick with an approach where I distribute the code for character-specific abilities into partials of the character class. You could also do a split where every functionality like movement or the ability to receive damage is available as different components so that you can also reuse it on non-character objects. But I only do that when the ability I want to add to the system is really independent and transferable to other game objects, which most often isn't the case or isn't really the case, because that usually hires the amount of dependencies to other game objects that I try to avoid in order to have maintainable source code. So let's open Unity and create a new project with the inbuilt render pipeline, because most of the assets that I would like to use for this game are not optimized for the universal render pipeline, nor for the high definition one. Give the new project a fancy name and we are good to go. After the creation process has been finished, I like to download all the purchased game assets that we need for our exploration phase and later for the game development. Please apologize that I don't use the 3D primitives like cubes, planes and others that are inbuilt in Unity 3D to do this tutorial, because the goal of this video series is to teach you everything you need in order to finish a game that can be uploaded to the Steam store. And you know, I'm a developer, not an artist, so therefore I have to buy the 3D assets. But you can absolutely use other 3D assets that you already own or that you have bought or created by yourself, as well as going with Unity inbuilt 3D primitives like cubes to do this tutorial. It is not necessary that you purchase the same assets that I own, and please keep in mind that this isn't my first game and I have collected a lot of assets over the years of game development. My tip is to leverage special offers and sales, discounts, in order to grow your collection of assets. Okay, open your favorite editor for C# code like Visual Studio Code or Visual Studio and let's code together. So the first thing we need to do is we have to replace the Unity callback function start update fixed update with some that we can call from the children of our character class. So we create protected virtual methods base update to call it from the children's update method. We create protected virtual void base start to call it from the children's start method. And we will also do the same for the fixed update. So protected virtual void base fixed update. So now we can ensure that we decide what kind of methods should be called in the base class, but we can also override it and add or modify the behavior of a specific character, like the range one or the melee one or the enemy character. Okay, then we will create a new file in Unity for our sensing behavior so that the character is able to identify other characters. Okay, therefore we have to create a new file and I call it character.sense in order to show that this is a partial class for the character class. Now we get an error because it's not allowed to have a class name with a dot, and we open that in our Visual Studio. And the first thing that we need to adjust is the naming. So now it's a public partial class. So it gets copy and pasted from Unity, and it usually acts like it is one class. Okay, then we will also copy and paste the namespace because I have a quite huge code base, and therefore I like to do everything I code in my own namespace so that I can avoid conflicts when utilizing source code that I have written in the past. Okay, and now we write the first update method for our sensing. Oh, and we also have to add the partial name to the first class. So it's a partial class character. Okay, so the sensing also gets an update method, which is a protected virtual void update sensors. And we will also define one variable protected float sensing range in order to determine how far a character can see and can get notified that an enemy is in his range. And we can later override it, for example, for the range character, so that he has a much more higher sensing range than, for example, the melee character. Okay, the next class that I would like to create is, or the next partial for the character class that I would like to create is our combat behavior class. So in this case, we will create a new file and I call it character.combat. We do the same thing as before with the sensing class. So copy and paste the namespace and all the header stuff that is necessary in my setup. We will also delete the standard callback functions from Unity. I will collect the events here. Okay, and we have also to rename the class, so it's public partial class character. Okay, and then we are good to go. And now we can work on the behavior to allow our characters to act in combat. Okay, the first thing that we need is a public variable from type team, so an enum that we have to define by ourselves. Therefore, we create a new enum in our namespace, which is called public enum team. And currently there are 2 teams planned. I have to change the indentation, sorry for that. Okay, we have the player team and then we have also the enemies team. Okay. Next thing, we need a target so that the character understands whom to attack. In this case, we need a public variable that I call target. And the next thing is we need some value to decide how much damage we can do to the target. So in this case, we will also create a public variable called attack damage. And we use the public variable at this point so that we can adjust them in the Unity editor, because every public variable gets exposed to Unity so that you can enter new values in the component selection screen. Okay, the next thing is we need to determine when a character can attack. So usually after you have attacked, the character has to wait before he can attack again. So we need 2 variables in order to do that. A public one to define the interval between 2 attacks, and we need also a protected one, which is a timer who counts the seconds between the attacks. So first variable is called public float attack interval, which is in this case 2 seconds, and then we need also a protected one, which is a timer, and this will start with a 0 value. Okay, the next thing that we need to do is again to write an update method, and in this case it's again a protected virtual one so that we can override it from our child classes. Okay, and I call it virtual void update attack according to our naming convention. Okay, the first thing that we need to check is if we have a target, because if we don't have a target, we cannot attack. So if target is null, then we can leave this function. Remember, the update method is called every frame, so we have to try to leave it as early as possible. Okay, the next thing that we need to do when doing attack is to rotate towards the target. So for example, a ranged character should always aim to the target, and therefore we need a new method that I call rotate towards target, and we also have to create it. So in this case, it can be just a private message. We don't have to override it from our children, but it might become useful in future. But for now, let's keep it private. Okay, and I will fill it with content a little bit later. let's continue with the update attack method first. So now we do the attacking interval stuff. So what we do here is we take our attack timer and we add the time that has passed since the last frame was rendered, and then we check if the attack timer is higher than the attack interval. And if this is the case, then we will reset the attack timer, set it back to 0, and then we will also start our attack. In order to make a proper handling of the animations of a 3D character, we will do this in a coroutine, because then we are able to control the timing for the different animation stage in the attack pattern. So let's first create the methods that we need, and then we will create the coroutine. So in this case, we again create a method which is a protected virtual enumerator, so that we can call it from a coroutine. And we need a target, so that we know, okay, whom to attack. And in this case, we will throw an exception. I know it's not very good code design, but at this point we will throw an exception because it is necessary to override this method from the child object in order to understand what the attack pattern should look like. Okay, so let's throw a new not implemented exception, and I guess we have to import the systems in order to get this exception type. So let's import first using, I guess it's system. Right, okay, and we also need an enumerator. I guess it's in system collection, and okay, we'll fix this by importing the using system collections. Okay, next thing, we have to start the coroutine. So start coroutine and then attack. And in this case, we also need as a parameter the target that we would like to attack. Okay. Next thing, let's fill our rotate towards target function with content. So, and I will borrow the source code from Brackeys because he has figured out how to rotate property with quaternions. It's a little bit complicated to do that. I'm used to use Euler angles, and therefore, yeah, we will just borrow the source code from him. Okay, the first thing is we need a vector 3, the direction to our target. And we can calculate it by taking the position from our target minus our current position. And then we need a new quaternion, and then a loquotation. And that is quaternion.loquotation to the direction. Okay. Next thing is we need a vector to decide how far we would like to rotate. I will call this rotation, and we do this with lerping, meaning that every frame we rotate the character a little bit. So in this case, this is lerp, and it's the transform.rotation to the loquotation, and we need this over the time that has passed since the last frame. Okay, and we also need this in Euler angles because this is a vector 3 and not a quaternion. Okay, last but not least, we need to apply this rotation to our current game object in order to rotate it. So we use the Euler angle, and we only want to rotate the y-axis, not all axes of the character, so that it rotates from left to right or right to left. So y value is rotation.y. It's not the vector, it's just the y value, and it's 0f for that. Okay, that's it for now. Now we are able to attack, and we are also able to rotate to our character. Okay, next thing that we need is we need a method to allow the character to receive damage. We will do this in a public message called apply damage, because this is usually not called by the children. It's called from other character characters who attack this character. So in this case, we need to know how much damage they would like to do. And then we will first check, oh, okay, maybe we need first some variables in order to determine how much life we have. So let's add new variables to our class. In this case, it's public int max hit points. Then we also need the current hit points that we have. So it's current hit points. And later we will do the same thing as we have for the attack interval with the invulnerability counter, because the behavior should be something like you get attacked and then you become invulnerable for maybe a second or something like that. So let's also add these variables now. So we also need the time. Therefore, it's a public variable. We call it the invulnerability time. Maybe it's also 2 seconds, maybe it's 1 second. And then we also need the timer, which is a protected float time since last hit. It's also 0 value, and we also need a public bool to decide if we are currently invulnerable or not. So is invulnerable, and we decide to do this as a property. Okay. So then let's continue with the apply attack method. The first thing that we check is if our current hit points is lower or equal 0, then we have to return. We can't receive damage anymore. Next thing is if we are invulnerable, then we also cannot receive more damage. At this point in time, we will also we will later also invoke Unity events when certain things happen. So for example, at this point in time, I would like to invoke the on hit while invulnerable event that we have to create in the partial character class for events. But let's do this a little bit later. Okay, let's first complete this method. So the next thing, if we got hit, then we become invulnerable as described before. And the current hit point gets also decreased by the amount of damage that we take. And then we check again if we are destroyed or not. So if hit points is lower or equal 0, then we need a method to decide that we have become destroyed. And we will also invoke an event so that other game objects can react when this character has been destroyed. But let's do the events later. Okay, else we also need to trigger the animator so that we see that we got damaged, and we will also oh, we don't have an animator object yet. Okay, maybe we add this first. Let's do this in the overall character. Therefore, because every character has an animator and it's not only related to the combat situation, therefore we will add it to the main partial class. So let's add the animator, call it animator, and this is something that we have to do in every character. So we can add this to the protected virtual base start method. So the animator is something like get component. In this case, the animator that is already on the game object, and we are good to go. Okay, and then let's come back. So if we are not destroyed, but we received a lot of damage, then we have to react to it. And usually we do that via playing an animation. So we will use a trigger and say, okay, we are damaged. Later we have to add all these trigger variables and parameters to all the different characters object, to this video objects in the animator, but we will do this later. Okay, anyway, I would also like to call now the event function for we have received damage. So we will create the Unity events CS first. But let's let's start with the be destroyed function because it's currently missing. So we add a new functionality which is protected virtual also void be destroyed. which is called when the character got destroyed. So when our health is lower or equal 0. And this is the situation when we play the trigger for the death animation. And then we also have to destroy our box collider in order to prevent others from taking us as a target again. So in this case, we take the box collider and say, okay, please destroy it. Then we also have to destroy this character so that it's not available in the game anymore. We will not remove the whole game object because we would like to see the dead character on the ground. That is the reason why we only destroy the box collider and also the character. Okay, next thing, we create the events class so that other game objects are able to react to certain events in our character class. So again, let's create a new class, call it character.events. Then we will open it in Visual Studio and again copy and paste the outer stuff. Then we have to delete all this functionality, rename the class, and in this case it's a partial class. Okay, I will correct the indentation. Yes, and I'm sure there is also a shortcut to do that, but I don't know it. Okay, then let's create some Unity events for all the things that happened so far. In this case, we have a public Unity event called on death, which will be called when we are dead, and on damage. And also when we become invulnerable, so on become, what is it called? When we become, when we get hit while we are invulnerable, like that. Sorry for that. Rebel. Okay. And now we can just call them from the different methods that we have. So if we are dead, then just take the index Unity event and invoke it. We will do the same thing for... It's not available. Maybe there is an error that I currently don't see. So on this should work. Okay, maybe we have to go back to Unity first, because otherwise Visual Studio does not understand. I missed an import. Sorry for that. Okay, let's go back and import the Unity event. So we need to import it in using the Unity engine dot events. Okay, and this is the Unity event. Sorry for that. This is a Unity event. Okay, not like that. Where's the import? I guess it's Unity engine.events public Unity. There's a spell. Okay, it's Unity event like that. Okay, great. Then let's continue. We will invoke the onDeath method when our current hit points is lower or equal 0, and we will also trigger the onDamage callbacks when we receive damage. Okay. Same thing for attacking. When we have attacked, we should also... sorry. It's when we become invulnerable. So then hit while invulnerable should also be invoked. Maybe we would like to display something like a shield. That might be a situation where we need this callback. Okay, then let's go back to our game, and maybe I show you what we have done so far in the Unity editor. So just create a new character. It's a game object, and then we will add the character class that we have created. And what you see here is all the public variables that we have created, as well as all the Unity events. And the good thing is that you can now just take other game objects and add callbacks so that these game objects can react when a certain event within our character will happen. So the next ability that we would like to add to our character is the movement ability, so that the enemies are able to move through the waypoint system and reach their specific level goal in order to win. So we need a character.movement, and we do it as the last time, so copy and paste all the header functionalities, the boring stuff. Okay, correct the indentation, also deletes the movement, and it's also a partials class for the character. Okay, so then we also delete all these callback functionality because we take them from the child objects, and now we have to define some variables. So first we need a float variable to determine how fast the character can move forward. So and I call this a forward speed, which is maybe a 3 as a standard value. We need also the variable that decides how fast we are currently working. So it's a current speed variable. Then we also need to understand what our last position was. So it's a vector 3 previous position. And then we also need to understand waypoints for this kind of game. So we have an array here and we call it waypoints. We will fill this later in the Unity editor. And then we also need a private variable to understand on what waypoint we are currently are. Okay, then as before, we need an update method. It's a protected void so that we can override it from our character class, so protected virtual void, virtual void. And I call this, according to our naming convention, update movement. Okay, the movement depends on the certain kind of movement that we will implement in the game. So for now, it's waypoints. In future, we will also have other movements like the patrolling of individual hero characters of the player, for example. But we will add this capability later. So first, to do the movement, we first figure out what kind of waypoint we have to follow. So we need to transform waypoint, and then we take from our waypoints array the current waypoint, which we have the index from. And if the distance, so vector distance between the transform, our current position, and the waypoint position is lower than 1.1, then we know, okay, we have reached our waypoint. Okay, and in this point, then the current waypoint index is the current waypoint index plus 1 modulo the waypoint's length of the array. Okay, with this, we make sure that if we're on the last waypoint, it will cycle around and restart again with the first waypoint. But when we reach the last waypoint, we will usually destroy our enemy and count a point for them or something like that. Okay, so we check that if the current waypoint index is again 0. In this case, we would like to call a function. I call this reach last waypoint, so that we can certainly react to this situation. And we also have to create this function. Okay, so it's protected virtual void, so that we can also override it, the behaviors that the child classes have when reaching a waypoint. So in this case, when we reach a waypoint, we would like to destroy the game object. Okay, next thing, if we have not reached our our target destination, then we have to move towards the waypoint that we would like to reach, and in this case we take the transform position. And we can utilize the vector3 function called move towards, and then we define that our starting position is the current position, and we would like to go in the direction of the waypoint position, and then we have also to decide how fast we would like to translate in this direction. So we take forward speed and multiply this with the time passed since the last frame has been updated. Okay. And then we also would like the character to look to the waypoint so that it always looks in the direction that he's currently moving, because otherwise it would look a little bit confusing. Okay, that's it for now, and this is our movement methodology method. Sorry, method, not methodology. Okay, and the next thing that we need is we also need to update our animation system, because usually what you do is you have a float variable and you have to pass the current speed to this variable, and therefore we need to calculate it. So therefore we have again a protected virtual void update movement animation, which we need to call. And in this case, we determine how fast we are moving with a vector 3 called movement. This is the current position minus our previous position. So we see how far we have traveled since the last update of a frame. So and the current speed is then, we need a variable to, no, we have a variable to do that. So the current speed is the movement dot magnitude minus time delta. That is the distance that we have traveled since last time, so the speeds that we had. So then we take the previous position and save our current position to the previous position. And then we can tell our animator that he should set a float variable that, according to our nomenclature, is called speed. And we pass the value of current speed to this animator parameter. Okay, that's how we update the animator in order to show that the character should move. Okay, and that's it with the whole character class system. Now we have the ability to sense the character. Currently this is empty. We will fill it in the first child that we create. We have the base class, we have also the combat behavior, and we have certain events to react while the character is doing some stuff. So in order to check if the character class is working, let's first create the first child. In this case, we will take the enemy and bring him to run in this scene. Okay, so let's create a new script and we call it enemy. Again, let's open it in Visual Studio. I copy and paste all the header information. Okay, and the first thing that we need to do now is we derive enemy from character. So this is the first character object in our game. So, and we have now the standard callbacks from Unity. I would like to put them in regions so that later I can sort my source code and it looks a little bit cleaner. So end region. In the start method, we will call the base start function that we have defined. That's where we set, for example, the animator for all the characters. And we will also determine the team so that for the sensing it's clear, okay, this is an enemy. And the next thing is in the update callback from Unity, we will call the base update. And we will also update the movement. Update movement and, sorry, and we will also update the movement animation so that the character looks properly. Movement animation. Okay, and we will also do the fix update and call our base fixed update there. Currently, I guess it was empty, but we will fill this later. Let's have a look. Yeah, currently it's empty, but we will fill this later. Okay, the first thing that we have to do is we have to override the attack pattern so that our enemy is able to attack a character. In this case, I will again put it into a region so that we can nicely collapse this here in Visual Studio. Okay, So we need now to override a function. So we override, in this case, the attack enumerator, so the coroutine that we have to start. And in this case, the first thing that we do is we trigger the attack parameter of the animator so that the character can play his animation to attack someone. Then we wait until this animation is finished. So we wait for seconds. In this case, it's, I guess, 1 second for this kind of animation. And then in a later point of time, when we do the development phase and not the exploration phase, we will figure out how long this animation is, or maybe we will also do the callbacks from the animation. But for now, it's fine and it's working, so we will use it. So, and then for the target, we will just apply the damage. And in this case, we have to pass our attack damage. And the next thing what we do is we call our target that he is being attacked. Okay, and we invoke here. And I see we do not have an event to do it. So in this case, let's add it to the character events that we have. Okay. So then the character can properly react to being attacked. Okay, next thing that we need to do is we need to figure out, we need to override the sensing update so that the character is able to see other characters. So what we do here is we override the update sense method. First, we do everything that is in the base class. Currently it's empty, but maybe we will add something. So first thing is we check again if we have a target. Because if we have a target, then we don't have to check for another target. Then we will also see... No, leave it out. Okay, the next thing that we need to do is we go back to Unity. And then we will look for a certain character model that we can use. In this case, I will delete our test character. And I will take one from one of the examples, or one from one of the boat assets that we have. In this case, we take a werewolf, and I put it on position so that we can see him. So let's put it on 1.69, and this is -8. Oh no, it's -10. And this is also -2, and maybe, no, it's 0, sorry. No, it's -2, okay, and now we need to rotate him, and maybe we also make him a little bit smaller so that he fits better to the scene. Okay, next thing that we need to do is we need to adjust the animator of this character and add all the parameters that we would like to see here. So just add a float parameter called speed. That is where we pass our current speed variables, and we need also a trigger while he gets damaged. And we also need a variable when he is deathed. In dem Fall it's the death trigger. And we also need an attack trigger in order to trigger the attack animation. So in general, we have an idle animation that is a standard animation that will be played all the time. And we have also an animation type called attacked, and we need a transition from idle to attack. And the condition to do that is when we have the trigger for, sorry, not damaged, for attack. Okay, when you click that, then the attacking will happen. And it's important it has no exit time, so it should act immediately. And we go back with the transition to the idle state. This has an exit time, meaning that when the animation is over, we will automatically go back to the idle state. Okay, next thing that we need is a hit variable. So whenever we get attacked or we idle, we would like to see without an exit time that we play the damaged or the hit animation. The reason why we do not do it to the any state is we would like to prevent having the hit animation be played while we do an attack animation. Okay, next thing that we need is we need some kind of locomotion. So in this case, it's the walk animation and also the run animation. Difference is that we use the walk animation when speed is something around greater than 0.1 or 0.01, and then we make another transition from walking to running when the character is faster than speed of greater than 0 dot maybe 1. Okay, and we go back in the same manner. So if speed is lower than 1, then we go back to work, and if we are slower than 0 dot 1, we go back to idle. Okay. Now we have, okay, we are missing the death one, right? Okay, death can be played from any state. So from any state, whenever the death trigger is triggered, then the character places death animation. And it's very important, there is no way back. So when we are dead, we will lay on the ground and we are done with this character. Okay, then let's go back to Unity. And the next thing, what we do, okay, these errors relate to an issue in Unity and not to our source code. The next thing what we do is we test if this works by assigning our character class to the Unity object, and then we should also add our waypoints that we have. At a later point in time, we will add them through the game controller, but we will do this in the next episode. Therefore, let's add them by hand. So we have waypoint 1, 2, 3, and 4. And when we hit play now, we should see that everything is working and that the werewolf is walking along the waypoint system. Okay, sorry for that. I have done a little mistake. We do not have to add the character class. Obviously, we have to add the enemy class because the behavior for the enemy is defined there. Okay, then again, let's add the waypoints. In this case, 4 at a time. 1, 2, 3, and 4. Okay, and we should now see that the character is walking. Oh, and I'm currently in debug mode, so just ignore that. And we see that the character is walking and that the animation is also be properly played. Okay, let's do it again. Our enemy is currently starting. Okay, the animation is not played directly, maybe because we missed to explain that it do not has an exit time. That is always the issue. If the animation comes too late, then it's usually connected to this exit time thing. Okay, let's go back, do it again. And now we see the character is directly moving. Okay, and it's following all the waypoints that we have. Okay, and the waypoint, just for your information, is just a game object which has a position. And for me to easier do the positioning, I also add some little spheres so that I can see them, and I disable them when I start the game. Yeah. Okay, that's it for this episode. To see the whole character system in action, we will play again the finished exploration demo that we have, but we will do all the other parts in the upcoming videos. Okay, here we can place the different characters, and then we can hand around, and then the enemies will spawn. There's currently an issue because usually they should spawn directly, but now they are waiting for the spawning interval. Okay, and we see the range character is attacking, the melee character is being attacked and is also attacking. And when the melee character is dead, then the werewolves try to reach their target. And that's it for the exploration demo for now. And we have come to an end, so thanks a lot for watching. And I will continue in the next episode. Thanks a lot for watching this episode of ILTPWC, and if you like to see me developing the whole RPG tower defense game with roguelike elements, consider subscribing, and we will reach the point together where I will upload the finished game to the Steam store, maybe mid of 2023, right? Okay, so stay tuned, and thanks a lot for watching this episode, and don't forget to play with computers, because we love to play with computers since the day we were kids.